And today I'm very excited to present an idea that I have been kind of like brainstorming over the past few months. I've been working in collaboration with a couple of friends at the Sandia National Laboratories. I would say, sadly, he couldn't come, but he has sent us a video to talk about what they are doing at Sandia National Labs and why this talk, right, best of both worlds, meaning the HPC supercomputing centers are looking into merging Kubernetes and Slurm, and this is something that they are working actively on. So with that, I will step and play this quick video.
Hello everyone, my name is Eduardo, and I am happy to be my first KubeCon. I am also, it is worth also mentioning that this is the first time I'm also getting married, hence why I couldn't make it. Now I'd like to introduce some of the topics that we'll be speaking about today. Our goal is to integrate Slurm with Kubernetes in a more cloud-native way. We'll be able to walk into some more details later on in the slides, and then to the demo as well. First, I'd like to tell you a little bit about myself. I work mainly or primarily in the government. I have 10 plus years of cloud computing experience, working with scheduling, container orchestration, DevOps, and runtimes. I am serving as a senior member of the technical staff at Sandia National Laboratories. And with that, I'd like to pass it on to Eduardo for his introduction.
Yeah, he kind of like open it for me.
Now
So
I'd like to continue with the agenda, which first provide an overview of Sandia and the supporting projects of this effort. Then we'll dive into some of the user demands that are driving this work, the pathway to Kubernetes from virtualization and containerization. And then we'll introduce K-Foundry's role as a framework for this work. Then we'll dive into some concluding remarks. And finally, we'll be able to demonstrate how K-Foundry works. At Sandia, the main mission is national security. Just to give you a glimpse of Sandia's magnitude, we employ over 100,000 employees, out of which 15,000 are engineers and scientists, as well as 95,000 plus contractors. Within Sandia, I work in the Center for Computing Research, in which our main objective is to create computer technology that addresses our nation's most demanding national security challenges. Within Sandia, the Advanced Simulation Computing program was created, ASC, which is a program aimed to do what has never been done before. And it is it's a tri-lab effort among Sandia, Los Alamos National Labs, and Lawrence Livermore National Labs. It has also an industry component in which we aim to bring the most cutting edge technology into the labs. It also has an academia component which aims to bring domain expertise to the labs. Now that we understand the ESC program, it is worth introducing some of the other projects that it is supporting. It is supporting the Accelerated Video Engineering, ADE program, which is a program is a project that is expanding computer needs through the pathfinding of hardware and software technologies. It is based on this, and the estimates that it would see its computing capacity in the next 3 to 5 years. For these reasons, NVIDIA requires a unified model infrastructure to better deliver computational power as a service. And this image right here is what we envision, is how we envision the new engineering science capability that blends experimentation, data, and compute together. Now that we understand some of the projects that support Sandia National Laboratories, it is worth now highlighting some of the user demands that drive new capabilities. In essence, traditionally, we present the HPC from a standpoint of interacting with it from the command line legacy. Now, we are heading towards an automated world, a more accessible world. This is the reason why these efforts are, new capabilities have to be enabled for domain scientists to actually perform work that is of interest to national security. We talk about the needs and the way we have progressed towards implementation. We have been working on virtualization technology since early 2000s, and now, for our first deployment of Kubernetes, we attempted to enable different aspects of the computing environment, and prototype to adapt different computing components. Hence, it is a list that is over the green circle. Now, as we continue to move on through in this new phase, we continue to push further into our production systems, as well as also continue R&D to research and to understand new capabilities within the space of cloud computing. Now that we understand also, our roadmap and how we have gotten here, it is worth understanding that K-Foundry aims to bridge the gaps across all computing. So we would like to leave the underlying infrastructure the way it is, and we like to interact with it without having to do many changes to it. We wanted to leverage cloud technologies that were already open source technologies to have more flexibility at the time that we start enabling. In this particular case, K-Foundry is actually we're leveraging KCP to enable. We're repurposing KCP to enable the interaction with multiple computing spaces or computing environments within Sandia. Our big opportunity here is that we like to take all the progress we've made in HPC over the years to essentially supercharge cloud ecosystems. In this case, it could be an in-house hybrid cloud ecosystem, or it could just be a public cloud ecosystem. We like to essentially bring the most cutting-edge resources and make them available to scientists without them having to become experts. Talking about experts, this is the way it is envisioned ultimately. Engineers and designers will navigate to a web portal of this that looks similar to something like this. Now, they would have a menu of simulations, and then they could pick their simulation, they'll be able to receive the resource interactively. And in essence, this effort aims to democratize HPC by offering this performance without requiring researchers to become HPC experts. We would like to treat HPC as a service, not as a special one-off resource. Finally, ADE, or Accelerated Digital Engineering goals, is to support diverse computing needs. Our solution supports in computing environments from Kubernetes clusters to large HPC setups. We also aim to support interactive and long containerized HPC applications. Sandia is committed to evolving our support for diverse computing demands, driving forward adaptability and efficiency of computational workloads. I'd like to thank all the contributors to this work. Still, it's an ongoing work. However, we continue to try to pave the way to enable this ecosystem. Now I'd like to move on to Eduardo, who will take over and actually demonstrate how K-Foundry works.
Alrighty, now we are here. So this demonstration, this first part of the presentation was to show the importance that many customers out there and users and the community overall has this need of merging what is a Slurm or Flux or any other HPC type of resource with Kubernetes. And as we saw during the presentation, they are even using Kubeflow, right? So it shows that even for national security purposes, they have the need to play with cloud native tooling. And this is key and important for them. So they need to have a way to have a Slurm, HPC, and also to have Kubernetes playing side by side because it's important for their mission. And the thing that we need to have in mind here is that depending on the mission, they have different clusters. Just at Sandia, not any other labs that he mentioned, they could have 10, 20, or 30 different clusters, and each one is set up for a specific mission, or we will say like a specific scientific purpose. So what I want to walk through here is how we got into the idea that we're working on. And the first thing that I want to talk about is the Kubernetes HPC efforts, right? Sometimes it feels that we are trying to use the wrong tool to get things done because we look at these HPC laboratories, we see them running a Slurm over thousands of jobs, and we are like, oh, let's try the same in Kubernetes, and we try it the hard way, right? And we have been making efforts as a community, right? Like even at this KubeCon, we discussed about working group serving and working group device management. There are the new working groups, but we also have the CNCF research user group, the Bash working group from CNCF, and the Bash working group from Kubernetes, and more to come, right? Like the need keeps growing, and it keeps growing the need for us to sit down as a community and discuss about what needs to be done and to bridge this gap between traditional HPC and cloud native applications. Also, as a community, we have done really nice things, right? Like the Project Q, the job set API. We saw Q exposed at the keynote on Wednesday, so it gets to show that it is already being used in production, and there is already customers like CERN using Q for like big scientific deployments. Also in scheduling, we have as a community the scheduling plugin that enables us to do things like the Flux framework operator. And also what was introduced recently is Linky from CRDs and distributed computing like the MPI operator that is still under the Kubeflow organization. But what's like the key role here for like the difference between a Slurm and Kubernetes? So when we say Kubernetes in this HPC conversation, we are basically referring to the kube scheduler that is the scheduler component of Kubernetes. It's a solution and containerized workload management is made for cloud native ecosystem, and it requires to enable plugins so you can run things like Slurm, LSF, the Flux operator that also allows you to plug in Flux into Kubernetes. But at the end of the day, the plugins that and the steps of the scheduling decision that this scheduling plugin gives us is not powerful enough, right? Like it falls short, and in any hallway track conversation, I keep hearing people like, yeah, it's not enough. We want to rewrite the scheduler. We did this, we did that. So everyone is coming with a different solution on how to bypass the kube scheduler. But Q is already demonstrating really interesting things, and Q attached with the leader working set and the job set API is taking us to new fields that we never dreamed possible for Kubernetes maybe 2-3 years ago. And now we see these demos being run at keynotes from CERN, where they are running thousands of pods and they are doing queuing and bashing on Kubernetes nodes. We are still far away from what a traditional HPC cluster is, but it doesn't mean that we need to get there, right? This is the whole point of the conversation. Kubernetes was made for a specific use case, and we are making it better to be the de facto resource management for infrastructure. But Slurm is still a tool, and we need to use it. We don't need to grow Kubernetes complex forever if there are tools there that we can leverage. So for those that didn't attend the keynote, Q, from a very high point of view, is a queuing operator. It's very slim implementation, so it basically doesn't consume resources and allows you to maximize the resource consumption or resource management of your Kubernetes cluster when you need queuing or batching systems in Kubernetes. And it has full compatibility with the ecosystem, which is a key thing that I want to drive towards this presentation. Is Q, as we all know, it works with Kubeflow, it works with Ray, it works with the MPI operator, and basically everyone is adding themselves to Q so they can leverage the Q APIs. But for those that are new to today's conversation, is what is Slurm from a very, very high point of view, right? So we are all used to looking at the Kubernetes architecture, and we know that there is the master node, the control plane, the worker nodes. So if we look at this picture from really far away, it looks like Kubernetes, but it's actually a Slurm, right? So it has what will be the login node, what will be the controller daemons that run on the worker. For us in the Kubernetes community is the worker nodes, and the Slurm that is what actually could be translated as the kubelet, right? So like this image is very interesting because if you look at it from really far away, it looks very similar to Kubernetes architecture. So showing that Slurm is also a nice tool and we can leverage it for what it is, right? And the thing that also we need to bear in mind is that Slurm has support for things like PMIX that still in Kubernetes is a far dream ahead. Right? The MPI operator is still not ready to support the standard of PMIX, and Slurm basically today runs on thousands of nodes on these national laboratories and is helping us with national security. It is used for, as we saw in the presentation, for big deployments for academia and research, but it's complex to maintain and it's particularly complex to maintain with containerized workloads, right? But what are the gaps? So as I said from the Q slide, one of the gaps is the integration with the cloud native tooling. And here is where this whole presentation came to life. It's like, we would like to also have the API set that we like from Kubernetes and enable specific cloud-native tools, but for Slurm, that as of today, it doesn't have integration with cloud-native tools, like let's say Kubeflow or things like that. And it's very challenging to learn. I keep hearing that it's harder and harder to get good Slurm system admins, and mostly it's because of the hype of Kubernetes. As like newborn students prefer to do their masters in something related to Kubernetes because it will guarantee them a job. So it's like we need to take these things into account when thinking in Slurm. Then how do we merge things? And there is a really interesting project born a couple of years ago that is the Kubernetes control planes. The Kubernetes control planes, or KCP for short, is a project that is aimed to have a Kubernetes-like control plane, but it focuses on just an isolated clusters. And initially, it was designed for the multi-cluster ecosystem, but it has been growing to support all sorts of use cases. And basically, is an easy API that you can plug on top of anything you want. So what we really like from Kubernetes, like one of the key features that we all like from Kubernetes as a community, as an ecosystem, is that it is a uniform API, right? And that's the API design, and when we are designing new APIs and we are creating KEBs to modify an API in Kubernetes, we know how hard and how big that is, right? Like APIs are the core of Kubernetes, are what we like. If you have an API, you can just move around from cloud to cloud. You can move around from bare metal to the cloud and back because you know that the API is going to be the same. So KCP allows us to have that, to have an uniform API where we can basically just plug in underlying solutions because KCP is Kubernetes without the concept of infrastructure. It's just the ITSI component. I think I have it here. So it's ITSI, the API server, and the controller manager. And everything else is gone, right? Like it's like a very trimmed down version of Kubernetes. So if we have this trimmed down version of Kubernetes that doesn't know what a pod is, what a container is, what a node is, but it does know what RBAC is, secrets, namespaces, config map, and the most important thing of all, it knows what a custom resource definition is. So it allows us to create APIs like we do for Kubernetes, but for anything we want. And in this case, Slurm. So we can create CRDs for Slurm jobs. So introducing K-Foundry, pardon the name, I'm bad with naming, and it's basically trying to address the idea of we want to run Slurm next to Kubernetes, and we want them to be friends, right? Like we want them to play nice along each other. But how do we reach the last mile? So recently, Slurm also released the Slurm REST-D, which allow us to communicate with Slurm via an open API 3.0 compatible. So basically, we can do HTTP calls to Slurm from a high-level point of view, right? It runs in two modes, so Unix socket or TCP, depending on your security or your use cases. For these specific use cases, we are going TCP, but it could also be run via Unix socket. In the security point of view, it runs via JSON Web Token, so that's the way you authorize against the REST-D API. So from a high-level perspective, what K-Foundry gave us, right? So users basically do a kubectl create job. It will get into K-Foundry, and depending if it has a label or a notation in the metadata of the job, K-Foundry will decide if this job goes to a regular Kubernetes cluster or a Slurm cluster, right? This is one of the characteristics that KCP brings to the table, is that KCP allows us to have multiple consumers. It is called consumers on the KCP API, but it's basically like multiple clusters. But how does it look from a more deep dive point of view? So we do a job request, KCP then puts this into ITSI, and we, using the controller manager, this all sounds like Kubernetes to this point. So using the controller manager, K-Foundry, you can look at it as a operator. Basically, K-Foundry is an operator. It reads that there is a new entry on ITSI from the CRDs that we define, that in this case is a job. And then depending if it needs to go to Kubernetes or not, it will launch it to Kubernetes. And if not, it will translate the CRD from a basic Kubernetes job into the HTTP call of a Slurm job, right? So it will do the translation from the CRD to the REST API call for Slurm. It will then run the post to the REST API of Slurm, and it will update the ITSI CRD with the information that comes back from Slurm, reporting the job ID, and if the job is done or not, and the logs, and you name it. It also provides a multi-cluster approach. So as I was saying at the beginning, KCP allows us to have multiple clusters with multiple definitions of cluster. And this is very important for systems like Sandia, where they have multiple clusters, and each cluster has a mission. So we could create like a job controller or a job router with labels and annotations to tell K-Foundry where to route the job depending on the job mission. And thanks to KCP and that we can create CRDs, we still have the concept of nodes and jobs into KCP now. So we can do things like kubectl get nodes, and actually what gets reported back are the Slurm nodes, not Kubernetes cluster nodes. So it's, we are basically translating the REST API layer from Slurm into Kubernetes CRDs. And with that, I will here. So I will run a quick demo. It's just to show. So on the lower side, I think if you can see it, I'm running just a wash on SQ. So I'm requesting Slurm to tell me if there are jobs running. Here I have the logs from K-Foundry, and here I will. More? there. It's hard to see. This is in the laptop already. So I'm going to run this Kubernetes job, but you can see here that it is a custom resource definition, so it's not a Kubernetes a batch B1 job. It's a CRD, but the rest is the same. Basically, I have the Kubernetes job as the API itself when defining the CRD, and I will run a sleep, right? Like all I want to show is that we can go all the way to a Slurm and back. So when we run this, hopefully well, it was running before doing the Zoom. Yeah, so I don't know why the last part is not showing. Maybe it's already to zoom out. But as we can see here, the job was deployed and is providing all sorts of metadata, and it's telling us that it has a job ID 2 in Slurm, right? I think we zoomed too much, and that's why it's not showing here. But yeah, it basically ran the job via Slurm and is reporting the status back from the job. So it's the job ID 2 and it's sleeping for 100 seconds. So what we can do now with this is that we can deploy jobs to a Slurm. We can delete jobs from a Slurm. And also the good thing here is that we can have RBAC. So we can map RBAC from Kubernetes to a Slurm users because it is being handled via the JSON Web Tokens, so we can create JSON Web Tokens per user in a Slurm. So we could create like a one-on-one mapping. Why is it not showing? It's weird that it's updating up there, but not here. But yeah, and with that, I'm going to open for questions. Huh?
Just type SQ without the watch.
Perhaps. I think I need to exit and get back again. It's not showing. Weird, but it's updating up there.
I didn't catch it during the presentation, but is K-Foundry altogether going to be open sourced?
Yes.
Okay. Do you have a timeline on that?
Yeah, next week. Yeah, so basically, I had it open source. Yeah, I had it open source when I was working with the Sandia guys, but for KubeCon we shut it down. But yeah, next week I will open source it again.
Cool. Thank you.
2 questions. One, can you still hit...
Can you?
Oh, can you hear me?
Yeah.
Okay, 2 questions. One, can you still hit Slurm normally with the setup?
Oh yeah.
Yeah. So if researchers like, I'm not gonna use this control plane, they can still.
Yeah, no. So a Slurm rest is like an optional thing, right? So you have your Slurm cluster running, and then you enable the Slurm rest, right? So once it's enabled, we can then run KCP and all this infrastructure on top of. But if you want to, you can still SSH and do your stuff, right? The whole point of this is to, in one of the slides that Angel was showing in this slide, is that, as you can see here where it says advanced DevOps, at Sandia, what they want to do is that they have a centralized GitLab, and like using GitLab pipelines, you could, or like Argo CD, or you name it, right? Like using Kubernetes abstractions, you could deploy to Slurm, deploy to Kubernetes, and get all the information back in what the promise of KCP is in a single API, right?
Nice. And then a little off topic, you said you used to be a Singularity engineer, right?
Yeah, I was one of the initial.
Yeah. Do you still see? I can ask that one later. But do you see more OCI containers used, or do you see Singularity containers still used? Like, has that?
All of it. I cannot speak too much because I'm not a U.S. citizen, and we will get into weird conversations here.
Sure.
but yeah, I think I can say they run multiple container runtimes because part of being security, a national security lab, they don't want to tie to one, so they run Podman and Singularity.
Thank you.
Are the rest of the SQ arguments that you'd normally provide just part of your resource spec? So like number of processes, ranks per process, that kind of thing?
Yeah. We can basically translate a Kubernetes job into a Slurm job.
Sure, so if I already know what my Slurm job looks like and I already have a submission script and I have a bunch of arguments that I make to SQ, are those just things I would provide to the spec in your resource?
Yeah.
Okay. And
yeah,
then
it will map back. So if right now I'm kind of like starting from scratch because I'm running a Slurm on the CRDs has like a Slurm on Docker Compose. So I'm basically running a Slurm here.
Sure.
But if you were like running a Slurm and you had like a big queue, what K-Foundry will do is that it will grab the jobs there via the reconciliation loop of the controller runtime and one by one translate it back to CRDs.
Okay, thanks.
Yeah, the same thing for nodes, right? Like you have nodes, and it will do the S-info, kind of like S-info, and it will translate the S-info response into the Kubernetes nodes. Of course, it's not going to fill all the fields of a Kubernetes nodes API, but it will do the best to fill that.
Thanks.
2 questions. How do you pass the URL of Slurm cluster from Kubernetes? Do you need to specify it in every job, or is it possible to specify once for each cluster in some configuration? So that's one question. And second, is it possible to get, or maybe you're already doing that, monitoring from Slurm into Kubernetes, the metrics, if Slurm has some logs and metrics, is it possible to get into Kubernetes world?
It's possible, but it's not, in what I have done for K-Foundry, is not yet implemented. But the whole idea is that since we have the Kube API server and ITSI, we can scrap as much information as possible from Slurm and then put it up as we are used to in Kubernetes with Prometheus, Grafana, and all of that for metrics. And your first question is not actually answered by K-Foundry. My project is basically answered by KCP itself. So it has primitives to attach clusters one by one. It is called a consumer. But yeah, you can basically attach as many clusters as you want.
So you talked a lot about the KCP to Slurm side of things, but I'm a bit confused how the KCP to Kubernetes side of things works, because KCP is a control plane, but it doesn't have a data plane. Does your Kubernetes cluster then have to be headless, or do you have 2 control planes that are stomping on each other? No.
It's so KCP initially, so when I started looking at it, it was just like a multi-cluster platform, right? Okay. So it's a control plane for routing jobs to different clusters. But your Kubernetes cluster can be a regular.
Okay, so it just submits it to the control plane at that cluster, and then that control plane takes over, and all it's doing is watching the state?
You can also picture as the concept of multi-cluster queue that was presented at the keynote, is you have a bunch of Kubernetes clusters, and you start routing jobs to each one.
Okay, it's just routing then. It's not actually a control plane for that cluster.
Mm-hmm.
Okay.
No more questions, so thank you, everyone, and we can go back home now.